In 1973, NASA sent 2 female spiders into space to study their behavior in weightlessness. The main goal was to see if spiders could spin their webs in a zero-gravity environment. This experiment helped improve understanding of how living organisms function in space and provided valuable information about the effects of space conditions on the behavior and adaptation of organisms. The objective was to examine their ability to spin silk in microgravity, and a wealth of information was obtained from this experiment. Could spiders still spin webs in microgravity? Fortunately, we owe the answer to 2 spiders named Arabella and Anita, sent to space in 1973. According to IFL Science, the idea for a spider experiment in space was proposed by a 17-year-old high school student named Judith Miles from Massachusetts. Her suggestion was part of one of NASA's projects that allowed students to submit ideas for experiments on the Skylab space station, the first U.S. space station. Skylab hosted several space missions for a brief period between May 1973 and February 1974. NASA welcomed Judith's idea and selected it for implementation in the Skylab 3 mission, the second crewed mission of the small space station. 2 European garden spiders were placed in small plastic containers and launched into low Earth orbit on July 28, 1973. Once everything was ready, Spider Arabella was directed into a special chamber to start her activities. Initially, due to the unusual conditions of space and microgravity, Arabella was unable to spin regular webs, resulting in simple and incomplete webs. However, after a day, she adapted to the new conditions and was able to spin complete and more orderly webs. The research team was interested in observing this progress, so they extended the duration of the experiment and introduced Anita midway through the mission. It took some time for the 2 spiders to adjust to the strange and unfamiliar environment of space, but they quickly learned to spin webs much like they did on Earth, although their webs in space were finer and thinner. The researchers' goal was not only to observe the behavior of the spiders but also to understand how conditions close to microgravity in space affect the central nervous system of living organisms, including humans. Orb weaver spiders are known for producing circular or oval webs. NASA explains, the geometric structure of the orb weaver spider's web serves as a suitable criterion for measuring the status of its central nervous system. The spider senses its own weight to determine the thickness of its silk and uses wind and gravitational force to initiate web spinning. Thus, when placed in the Skylab space station, where gravity is absent, the lack of gravity alters the spider's behavior when constructing webs, leading to different reactions. Unfortunately, neither of the 2 spiders survived, as Arabella and Anita likely died in the space station due to dehydration. Since the 1970s, several experiments have sent spiders into low Earth orbit to better understand how life adapts to space conditions. Recently, scientists from the University of Basel studied the behavior of golden orb weaver spiders, Trichonephila clavipes, aboard the International Space Station, paying special attention to the symmetry of their spun webs. On Earth, spiders spin their webs in a way that the center is slightly tilted upwards, rather than being right in the middle. This helps them quickly move down to catch prey when an insect hits the lower part of the web, aided by gravity. Interestingly, the webs spun during near-zero gravity conditions on the International Space Station were more symmetrical than those spun on Earth, with the center being closer to the middle. This indicates that even without prior experience in space, spiders quickly adjusted their behavior to adapt to the new conditions. This experiment helped scientists understand how low-gravity conditions influence the production of spider silk. The results not only enhanced understanding of living organisms' behavior in space but also led to advancements in fields such as materials engineering and molecular biology. These studies have shown that webs produced in microgravity differ significantly from those made on Earth. Additionally, this project contributed to the study of biological processes under unconventional conditions and their effects on evolutionary processes. Ultimately, sending living organisms into space was not only a scientific endeavor but also related to research on life in space and the possibility of life on other planets. What effects on spider behavior and silk production were observed in a microgravity environment? Thank you for staying with us until the end of the video.